Yeah, so this is all about building GP tools with Python. I'm Dave. This is Drew.
Yeah.
Here, I'm gonna let you take over on here. Say something.
Who are you? Introduce myself. So I'm Drew. Yeah, as you can see, I think I work at Esri.
Yeah. Where'd you get that picture
show
from?
up. This one. So this was taken in the Esri cafe. They were taking
one
photos.
of those ones.
Yeah, for the website, for the career website.
Okay.
And they said, let's do like a hair flip one, and then this is basically what you see when you talk to me at work now. If you like chat me up on Skype and stuff, you'll see this ridiculous picture.
Yeah.
I've cut my hair since then too. It's a lot shorter.
Yeah. All right.
But yeah. So yeah.
What do you do?
I mean, I show up.
Yeah.
Yeah. And I do some Python stuff sometimes. Yeah.
Yeah. All right, cool.
Yeah.
So I didn't mean to put you on the spot.
No, you're good.
Yeah. Drew does some pretty cool stuff, like building like some of our Python test harnesses and other things. Me, I've been at Esri now for a long time. Been on GP the whole time. Kind of the whole history of myself here at Esri has been working with GP, working with Python. More recently, I've kind of taken a lead doing a lot of documentation work on Python and geoprocessing. The whole cat guy, dog guy thing, that'll become more clear later, right? Yeah.
Yeah.
All right. Okay. So if you looked at the abstract online or in a schedule, this is what you saw. So this is going to be kind of a session building up, what Python and geoprocessing tools is really about. I'm not expecting like a whole lot of I expect most of you have at least some background in Python. You understand at least a little bit about what GP is. We're kind of build up some knowledge and understanding of what that framework is all about and how you can take advantage of it to make your own tools, make better tools. The list of topics at the bottom is kind of the concepts that we're going to go through today. All right, here we go. All right, so really, when you build a GP tool and you build your own GP tool, you're basically being able to leverage the whole geoprocessing framework that we have across multiple products, right? So you build that tool and you can use a tool that in the same way that anyone else can use a system tool, right? So you get the dialogue experience from it. You can call a tool from Python, ModelBuilder. You can turn those tools into services. You can package them. All these different ways you can use geoprocessing tools. Your tool can become part of that. Now, towards the end, we'll actually talk a little bit about if you're migrating from desktop to pro. We'll talk about that. But the idea with the tools is there's really been a long history to this. This isn't a new thing. We're continuing to improve it, but experience of being able to create geoprocessing tools is a long-running capability that we have. So the idea is, even if you build a tool now, this isn't something that you're going to have to, toss away in a couple years. This is something that can really have a long-lasting future ahead of it. Right, so the work you do now can be consequential even many years down the road. All right, some random fun facts. So geoprocessing framework that came around 9.0, that's 14 years ago now. ArcGIS Pro has about 1,200 tools. Desktop has something similar to that. Of those tools that we have, about 10% of those right now are actually Python-based. There's some toolboxes that are very central on Python, like spatial statistics, but there's a kind of a hodgepodge of tools in a variety of places. I'd say actually probably a quarter to a third of those, are ones that, I've built or have been involved in creating. All right, and today, because there are two flavors of building tools with Python, there's geoprocessing script tools, and there's also Python toolboxes. We're gonna go back and forth and cover both of those concepts. Script tools being kind of the golden oldie, Python toolboxes being something that's a little more recent. All right, so if we break down kind of just into big silos what a geoprocessing tool is composed of, it really breaks down this way. There's the parameters, which kind of guides the basic interaction that you have with your underlying code. There's validation that you can optionally do, and that's kind of a way of fine-tuning that experience, the interaction that someone might have with your tool, and then ultimately the underlying source code. So the graphics here, this is kind of you see the two basic modes, right? On the left, that's more the script tool approach, where it's broken up a little bit, and then the Python Toolbox on the right. So let's go kind of through some basic mechanics of how this all kind of works. So in a couple minutes, Drew's going to open up a tool that he's been working on and kind of step through some parts of this. But ultimately, you double click on a tool and it opens up. And all that happens there is the tool parameters are being initialized. So the definitions you created, that comes up, and you have that kind of initial starting state. After that, every time you make a change in that dialog, every time you take a parameter change, you delete something, you add something, you change a value. Every time you then click away from that, it triggers this validation step, right? Now, there's three really parts to that. There's an update parameters, which is optional. There's an internal validation stage, which is sort of simple checks that we build in. And then finally, there's this update messages, which is also an optional thing you can do. Now, right, each and every time you click, right, and you click, change something, click away, that gets fired. So just to kind of tease ahead, so let's be conscious of what you have in there, right? It's a very repeating kind of step. Oh, did we just lose my screen? No. Is that one blank? Oh, that's awkward.
It's plugged in. Yeah, let's see. Loosen up.
All right. Oh, here's our tech guy. Okay. So for a moment, just stretch your neck and look way over here. Okay, so those three stages, right, it's a continuous effect, right? So every time you make a change, that validation, those three basic routines get fired. Now, an internal validation, these are kind of simple checks. They're very, very quick, very, it's not like a lag. It's just simple things we're doing really based off of just your parameter definitions. Like, does, the data set that you've supplied, does that actually exist? Does the values match the filters that you've supplied, right? Like if it's a set of keywords, right, we'll check that the keyword entered matches those choices. Sort of simple checks like this. Now, once all that happens, and you get the tool in kind of a ready to go position, right, you're gonna hit the OK or run button, right? The arguments go down to your script, and a script tool you're calling a PY directly. Python Toolbox, there's an execute method, which we'll talk about a little bit later. Either case, arguments go down, right? Tool starts running. Now the values get picked up inside your script with GetParameter or GetParameter's text. Now, I'd probably say 95% of the time, you're gonna use GetParameter's text, and it's gonna give you whatever your argument is as a text string, right? So data path, keyword, whatnot. A few times there'll be things like you'll have like a Boolean parameter, you'll have numeric types, you'll use GetParameter, and that'll convert your value into a Python native type. All right, so the school starts running, and really, inside that tool, it can be anything you desire, right? It may be a bunch of tools, it could be something that's not related to ArcPy or GIS at all, right? Whatever you want, you can put in there. There are a few places, though, where you can make sort of communications back with the application. All right, if you have messages you want to send in, there's functions like add warning, add error, add message. There's also ways of modifying the progressor, right? So the little bar goes back and forth. You can convert that to a step progressor and indicate progress. Something that we added in the last couple of years, you can also deal with cancellations. It used to be that when you cancel the tool, it was just like a hard cancellation. Basically, your tool is abruptly ended where it is. Now, there's ways you can opt into of dealing with that, right? So you can sort of respond to the cancellation and kind of exit on your own terms. Now, most cases, most tools have outputs that are specified inside the dialog. But some tools, of course, are going to, they might calculate something, or they might create data that wasn't actually entered. It's somehow dynamically created inside the tool. Those are derived, we call them derived parameters, right? Sort of equivalent to having like a return value off of a function. Well, we push those back to the application with either set parameter or set parameters text. And then ultimately, the tool completes. If it's successful, it adds the output to the map. If you've assigned a symbology either as a parameter property or inside your code, right, that'll get affected, and then the result will get added and updated inside the application history. All right. Okay. What have you got to show us?
So I've got a few things. Let's switch over to my screen here. And yeah, that looks good. So I'm going to put kind of into context everything that David was saying and show you kind of how a script tool works from its initial conception. So I've got some data here that I've put together called Redlands cat sightings. And these are just various cats that I've spotted along my commute to Esri every morning. And in this data, I'm trying to organize the cat data to make it easier to figure out which cats you can approach, which ones you should not approach. And so I've got kind of this data which describes the size of the cat, a little bit of a visual description as well as the friendliness rank. So my data, for the first cat that I have, I got this orange cat. It's about a size 3 cat. And we got a friendly rank of 1. That's my little Boolean indication that the cat is indeed friendly. You can pet this cat. Same for the black and white cat. It's a little smaller, size 2, also friendly. I got a really small, skittish Siamese cat. Pretty sure I saw a saber-toothed tiger. And then once I thought I saw a cat, but it was just a ginormous raccoon. And it was not friendly. Don't touch the raccoons. So we're going to use that data to make myself a summary and just report which cats are friendly in and around the Redlands area. And we're going to use a script tool to do that. So the first step is to figure out what I want to code. Really, you want to start with the sort of Python logic that you're going to follow if you're building a script tool. So let's real quick open up the analysis pane and then open up the Python interpreter here. And let's do a real quick sort of kind of mock-up of what my tool might look like. I'm going to open up a search cursor, which is going to allow me to iterate over this table that I'm working with and run a little SQL query on it to report only the cats that are friendly. Just give me back the data for friendly cats. So let's type that up real quick. So with arcpy.da.search cursor, I'm going to choose my Redlands cat sighting.
Control ++. Yeah.
Like this?
Yeah.
Oh, there we go. Thank you. So we'll just return all the fields for now in the search cursor. This is how you indicate which fields you want. And this is the important part. This is where my query is going to be. So let's type friendly equals 1. Well, that'll let me get those friendly cats reported. And let's call this SC for search cursor. So I'm going to open up the search cursor. I'm going to, for every row in search cursor, I'm just going to print the row. And we'll run it. We'll see what we get. There we go. And I got 2 rows. Perfect. These are the friendly cats, the orange one and the black and white one. So this is, we're going to clean this up, clean this logic up, or clean this output up rather, and utilize this in our script tool. So let's make a script tool. I have this project folder here where I'd like to make my new script tool. In order to do that, I need a new toolbox. So I'm going to right click on the folder. I'm going to go to new and then toolbox. When I select that, I get to name the toolbox. We'll just call it a dev demo for dev summit demo. And I've created an empty toolbox. It's ready to create a script. If I try to open it up, nothing's there. If I right click on it, I get the new option again. I can just go to script. And in this screen, we're going to be seeing this a lot through the 3 demos that we have. We'll just concentrate on this general window for now. We're just going to type in a name that the pro is going to recognize this as. If we wanted to include like spaces or something, it's not going to let us do that. It's going to make a red box and tell us that we're not allowed to do that. So we can use like underscores to do that. So we'll do something like, or maybe, or just, there we go. And for the label, we can include spaces and underscores, which we can't do in the name. So we'll just call it a script cat. That's not a great name, that's okay though. For our script file, this is where you basically point to the logic that you want your script tool to have, where all the good stuff is happening. So in this case, I already have a script file. I'm just gonna browse to it and select it. As you can see, it's just a regular old .py file. If I click OK, it's going to allow me to select that file as the script file for the tool. And then if I just click OK here, I've created a script tool. Pretty easy. So let's run it and just see what it does. And then we'll look at the logic inside of it. If I double click on it, it opens up this geoprocessing window for me. I've got my parameter window selected at the moment, but there's no parameters set up. There might be later on, but for now there's no parameters. We also have this environment window in which we can change sort of some of the, we'll say like spatial related sort of attributes of like what we're working with. But for now, we're not going to create any data. We're just doing a little report on the friendly cats. So in this geoprocessing window, I have this run button. I can click on that to see how the script runs. That was super fast and gave me a nice green message here saying it's completed. If I expand that a little bit, I see that I got some output telling me which cats are friendly. And it looks a lot nicer than what we saw in the Python window. So how did I sort of do this? Where's the script for this? Well, I have this text editor here called Sublime 2. It makes things really nice and easy to read. I like the color coding that it uses. And I've got a little bit of logic here, which should look familiar. I have my search cursor, just like I had in the Python window. But up here I got some variables that are kind of hard-coded paths or strings. In this case, I have a path to the table that I'm using. This is the table that you saw in Pro, and that's just the full path to it. I have my field names that I'm using in the cursor. In this case, I'm using the OID, which is the like the 1, 2, 3, and 4 that you saw, and the type, which is like the orange, black and white raccoon that we saw. And we also have a SQL query, which is friendly equals 1. I've got my little output string here, which is empty for now, but we're going to be formatting that in the search cursor. And as soon as I fire up that search cursor, I'm just going to write a little message here. It says friendly cats. And for every row in the search cursor, I'm going to make this little sort of reporting string. It says OID equals and then a description of the cat. After that's all done, I just use this arcpy add message function to add the output to the geoprocessing window. And if we go back to Pro, you'll see this is exactly what I have inside the script. So super easy, right? It's all that logic is in the Python script itself. Now, as David mentioned, we can also use ModelBuilder for this sort of thing. So we just made a new script tool, but I have that one right here as well. And I've created a model inside of my toolbox. If I double click on that, or sorry, if I go back, I can run it. I can show you that it works the same as the script that we just wrote. So yeah, same reporting system, looks good. It's because it actually calls the script tool in the model. So if I right click on the model and then go to edit, you'll see that all that's in here is the cat query script. So that's exactly what we just saw here, and it shows that you can call those script tools inside of a model if you want to integrate your workflow into a ModelBuilder like that. I think that script, that is actually perfect.
Yeah.
Yeah, and I think...
Is that real data? How did you collect that?
It was like custom, just sort of, there's a cat. I'll write that down at work when I get to work, that sort of thing.
All right, looks like we got our second screen back.
Let's do...
Oh.
There we go. Okay.
All right, still there. All right, thank you, AV guy. All right, so one moment of philosophy here. So when we build geoprocessing tools, kind of as a overriding kind of concept, and we try and make GP tools that are sort of like one kind of elemental thing, right? The basic concept of the toolbox is, right, you got this huge toolbox of stuff, you kind of sequence it into the bigger workflow, right? take all these little steps to achieve kind of the bigger goal, solve the bigger problem. So when you create geoprocessing tools, I mean, you can make tools that you can throw the whole kitchen sink into, but conceptually, it tends to work a little better if you break them down into their smaller components, and then use things like Python or ModelBuilder to kind of sequence it out into something bigger. Now, a few years ago, actually a number of years ago, we created internally, had this list of geoprocessing tool commandments. Now, I'm on the core GP team, but we're not, the only team at Esri that builds geoprocessing tools. I'm good at GP, but there's all sorts of other, technical areas where they're the experts in those areas. So they build geoprocessing tools too. Now, it's not, so we got all these different people building geoprocessing tools. Some of them, know a little bit of GP, some, maybe not enough. So we constructed this. It was a much bigger list because it was for, function tools. But this was a good place for some of these people to start to kind of avoid like major pitfalls. So the second one is actually one that I think is probably the most important of these. We were talking about the validation and how that works, right? That gets triggered a lot, right? And when you're in a dialogue, you're usually kind of expecting fairly quick responses to your parameter choices, right? You make this change, you don't expect like this huge chunky lag, right? So generally speaking, try and keep, whatever you have in the validation to the small things. Like you're not gonna read in like a data set or run geoprocessing tools within validation. It's more kind of like simple checks, what's this data property, does this thing have a value, simple checks like this. I added a few more kind of on top of that. Number 8 is kind of one that I like as well. When you have a geoprocessing tool, you kind of want to avoid splashing up like the big red ugly error at the beginning, right? You just want to have a nice presented, neat, tool design without like an obvious like, oh, something's wrong kind of situation, right? That's something that, people visually don't respond well to. All right. So a little compare and contrast of the two major flavors that we have. So script tools, like I said, it's kind of been around for a while. It's more of like a UI-based kind of experience for creating it, right? You kind of go through this UI experience to build up your parameters. You'll see that in your next one, right? And you do some validation, but it's kind of hidden in the toolbox, and then you ultimately call your source code. That compares with Python Toolboxes. So Python Toolbox came around at 10.1. It's a entirely kind of Python-based solution, right? I don't like clicking through the UI endlessly, right? Python Toolbox, it's all code. You can just write it out and that tool. It's a little bit more responsive because you can avoid that kind of UI experience when you're building it up. But ultimately, whatever your preference is, the functionality between the tools, you can create the same tool in both ways. It's really just a matter of what your preference is in the creation stage. There are a few subtle things I just want to pick out. Like a traditional toolbox TBX file, it can include different tool types, right? He had a model there, right? You can have a model inside one of those toolboxes. If you have data interop, it has a little mechanism for creating a tool too. Different kinds of tools can sit in the traditional toolbox. PYT, of course, is just the Python Toolbox tools. For a long time, we didn't have security on Python toolboxes, but now I think that was about 2 releases ago, we included that. So there's different ways, if you want to hide your source code, you can do that on both toolboxes and Python toolboxes now. And the only other little change I want to note is licensing. Python toolboxes have an explicit method in the tool class for checking that kind of thing. It's much cleaner. If you want to do something similar in a script tool, you have to somehow kind of embed it in a parameter, and it's a little more awkward. Now, speaking of parameters, so parameters really kind of drive a lot of the different parts of how a tool works, right? It's what you get presented with when you look at it, when you're interacting with it, you're supplying values, you're checking those values, they get sent in, they come back out. It's a big part. So when you're constructing parameters, there's really, I guess, like three big ones, right? You're always going to have a data type, you're always going to have a direction, and then the parameter type. Things like name and label, well, okay, yeah, they're important, but not too exciting. Now, there are like 130, 140 odd data types, and it's kind of an intimidatingly long list. If you've ever gone through that and looked through it, and it really breaks down to there's probably like 10 to 15 data types that you're going to be working almost all the time in, right? It's the sort of obvious data ones, you know, feature classes, feature layers, rasters, tables, these kind of things, and simple like scalar types, like booleans, strings, that sort of thing. You can also kind of work that a little bit. You can take combinations of those and create like a value table experience. You can also make a composite data type and combine data types together. So you have sort of like one control with multiple acceptable input types. All right. It's my splashy PowerPoint animations here. I got a little bored a couple nights ago. This was before the hippo thing though. All right. So yeah, so these are all other properties that you can change and modify and work within your tool. You know, default is when you're gonna have a lot of time, an optional parameter, you have a default. One thing you can also do is you can set an environment as your default. So if there is an environment, it'll pick that up. It'd be hard to make a tool without having a filter. Filters are ways of kind of narrowing down your choices beyond just like the simple kind of data type check. So this would be cases like you have a set of keywords you want to use. Well, that would be arranged as a filter. You could use filters to like limit the geometry type of your like feature class coming in. Say you only want polygons or polylines. That's what kind of filters are used for. And then dependencies can happen really in two cases. You'll have some cases where you have like an input-output. You get into that a little bit more. It's kind of more ModelBuilder related. But also there's certain data types which are very kind of, they don't have any context on their own, right? Like a field parameter, those fields have to come from somewhere. So you have a parameter dependency back to some kind of data source. That's kind of what the dependency types will give you. All right.
All right.
So actually, this is still me.
Oh, it's still. Oh,
Yeah.
this is your demo.
I created my own little demo.
I got excited.
Demos are the best part. So, this is almost. I don't know if this is a demo. This is more like an aside, something that I use a lot. This is a Jupyter notebook, by the way. If you haven't seen that before, I'm not doing anything special. Jupyter notebook, really, it's just kind of a way of organizing some code. There's a function called GetParameter info. I'm all into like patterns and kind of seeing what other people do. You know, I don't like reinventing the wheel or really thinking for myself too much. So sometimes, you know, you can use GetParameter info as kind of a way of looking into other tools. So, you know, for instance, you know, there's a tool called Summary Statistics, and it has, well, let's just look at it quickly. Using GetParameter info, right? Just putting that into an ordered dictionary, right? So you can see there's 4 parameters. You know, this one's a little interesting. Oop. Bring my mouse. Right, that's simply a composite data type, right? That's kind of the combination of 2 different data types together. But this one here is a value table. Okay, that's interesting. And if I want to dig into that more, right, you can get at all this information through the code, right? So value tables are organized by columns, right? So you can see, oh, okay. And if you wanted to create one of these too, you would be basically following this kind of structure, right? So the columns are organized as lists of 2, right? I got, looks like the type and the name of the column. And I can deviate into there a little bit. Both of those columns have filters. I have this is a field, right? So it's filtering out certain field types, you know, by that nature excluding other ones. And then the second part, right, that's just a set of keywords, right? That's another filter. The other thing you can kind of do is you can dig deep into like a whole cross-section of tools. Like if you're looking for certain patterns, did that just blink off? Was it doing that weird thing again? Sorry. Yeah, I got that little compressed, like little window thing going on right now, so I don't know if that's related. All right, so you can always kind of look at a cross-section of tools, and I do this a lot too, where it's like certain patterns where it's like, this is what I want to do, but I'm not exactly sure of the effect. So I can go and I can look at other tools, kind of mine them for that kind of information, and then I can go and look at that tool more specifically. So for instance, this one, I'm just digging in, looking at a whole bunch of tools that have, they're a derived parameter with a workspace data type. All right, and okay, so speaking more about parameters, this is just kind of a compare contrast between the script tool and a Python toolbox. When you have I'll let you show more of the script tool side because that's more kind of UI based. But Python toolbox is really all it is defining parameter objects and setting the key properties that you need. So the big 5 again, give you name, display name, data type, parameter type, and direction, right? You'll set those every time, and then any additional properties or something, typically I then set after. So this one is this isn't like a real tool, this is kind of a little subset, because I didn't want to make the font too small, but it's an input feature layer parameter and a field parameter of a dependency back, right? So it's just creating those 2 parameter objects, adjusting the properties after. It can set like a filter, limit my geometry on the input, and I can do things like I can create an absolute value, create a parameter dependency back to my input. All right.
All right.
Hey, your turn.
Yeah. All right, cool. So that looks good. Let's talk a little bit about that Python toolbox that you mentioned. As David said, there's sort of your choice if you wanted to use the script tool or the toolbox. You can get kind of the same functionality from either if you code them the right way. So I made a toolbox already in my folder here. It works with the same cat data and does the same thing the cat script tool does, and it's a toolbox, so it's the cat box. And the cat box, you can see that there's a tool inside there. If I right-click on not on the tool itself here, or the script file itself here, but the PYT catbox file and go to edit, that'll open up that code for me. So I'll go to edit here, close this extra window. And you can see this is, I know it's a little zoomed out, but for comparison, this is the same functionality that we see in the Python script tool that I had a moment ago. So here's the script tool, and then here's the toolbox. And there's quite a few functions here which you can read about online, and they kind of tell you what they do. But down here in the execute function, that's where the good stuff is, the search cursor and things like that. So let's run this real quick and just see what happens when we double click on here and run it. Oh no, it failed. So it's okay, I meant for that to happen because I wanted to show you what it looks like when something does fail. It's red and scary instead of green and nice. But it's the same sort of area that you're seeing the report of that geoprocessing tool. If we want it to pass, we'd have to, we close this up. We can right click on the PYT file, edit that, go right back to the script where I was in. And we'll fix up this code really easily. I just needed to switch that, and I have a feeling it'll work now if we run it. There we go. So easy as that. Open it up in the editor and run it just like that. Same report, same functionality. So moving back to the script tool though, I'd like to improve my already amazing script tool with some parameters. What does that actually mean? Well, let's open up a script tool that uses those parameters that you mentioned. Here's a couple right here. And this is going to enhance my cat reporting system a little bit. So in the first parameter, I've got this feature layer, which is a drop-down menu. If I click on that, it just gives me a list of all the files, or all the feature classes, shape files, whatever I have in my table of contents. I can also browse to those using this little folder icon here. But for now, let's just select the Redlands cat sightings data. And this looks like a little text box here for friendly rank. I'm guessing I need to use the number 1 if I want to figure out which cats are friendliest, and that'll give me the report. So now that I filled that out, if I actually click or tab away from that parameter, you'll notice that little red asterisk goes away. I can bring it back. And that's just telling me that this is if I hover over it, it tells me it's a required parameter. So I have a little more functionality coming from the tool, sort of telling me how to use it and what to expect from it. It's kind of nice if multiple users are using something that you've built. So if I run this and it completed successfully, I have just some output with a little more robustness. It's actually telling me that I'm reporting on the cats with a friendly rank of 1. And I bet if I put a 0 in here and ran that, ooh, cats with a friendly rank of 0, the ones you don't want to approach, they're in there. So I have this really cool sort of flexible functionality for my tool now that I've added parameters. Let's look at the code for that so we can compare it to the previous code I was using. I'll zoom in here. Does that look readable on the big screen? Okay, we're good. It's hard to tell from the angle here. But here's the first script tool that we used, and then here's my new and improved script tool. So I cleaned up my imports a little bit. I'm just importing functions directly from ArcPy instead of importing the entire site package. So that might give me a little bit of a performance boost. Kind of negligible in this case. I also have a couple of these right here, these variables that are apparently something called GetParameter as text. Well, this is what sort of powers the user to input whatever they want into those tools and then have the tool run according to the input that was utilized. It gives that flexibility to the script tool. I'll explain that in more detail in just a moment here. But other than that, what we have is just the where clause, which is formatted using the friendly value. So if I have a 1 or a 0, it doesn't matter. That's what gets put into the where clause using the format function for a string. And then I have my field names, which I was using earlier. Same thing, open up a search cursor, and you can see that I have output being collected and then reported on. Also have this nice little logic here saying if the output's completely blank, well, there were no matches found. It means we opened up the search cursor, ran the query, and there weren't any matches found. If that's not blank, then I have some matches, and it's safe to assume I can just print out that output safely. So let's see how the script here interacts with the script tool itself to grab those parameters and make this more flexible. If I right-click on the tool and go to Properties, we're back to the screen that we saw earlier where we just edited the name and the label in the script file. But I'm going to click on the Parameters window right here. This is a table which lets me control what parameters are in the tool, which ones show up in the interface when I open up the script tool. So in this case, I have the two that we saw. I have the feature layer, which is where I selected that cat sighting data. And I have the name, which is, again, very similar to the script tool name. It's something that Pro utilizes, so there's no spaces allowed there. But you can include underscores. I have the data type, which you mentioned there's a whole bunch of these things. So checking them out online and seeing which ones are best for your workflow is recommended, just to familiarize yourself kind of with what options you have. And if you actually click on the ellipsis button here, you can select which data type you have for this particular parameter. And as you can see, there's a humongous list of all the different parameters you can use. In this case, I'm just going to use the feature layer. And for the friendly rank, I'm just going to use a long integer data type. These parameters can be required, like mine were. Remember they had that red asterisk next to the parameter name before I filled it out? That just tells you this is required. The tool will not run until that's filled out with something. I can also have an optional parameter for that. Or I can have a derived parameter. A derived just means you're actually creating output, typically. So the derived is something that's created from when the script tool runs. And in this case, you might want to name a feature class, and then it gets created with the name that you specified. But in this case, I'm just going to select required for both my parameters, and that'll be all we need. So these right here, the feature layer and the friendly rank, those get I guess, exposed to the Python file itself through this GetParameter as text. Or there's other options too. GetParameter is another one. But in this case, the order of the parameters matters. So in Pro, I see I have the feature layer as the first parameter and the friendly rank as the second one. They coincide with row 0 and row 1. That translates directly into how I grab those in the Python script. GetParameter is text 0, retrieves the in table or that feature layer, and then number 1 parameter retrieves the friendly value, the 1 or the 0, whatever I'm using. Let's see. I also have this option to sort of, remember I could control, let's see, which values were actually available in the tool for the friendly rank. If I try to enter something like 99, something ridiculous, it's going to give me an error that says the value's out of the range from 0 to 1. So I've created this functionality for users to see that what they've picked was actually not something that the tool can use. And I did that using the properties window in the script tool. So if I zip to that real quick here, notice that my filter says range. And if I click on that, I get a minimum of 0, a maximum of 1. I've just specified those. Great way to narrow the usage, make sure that it's not something that can be used incorrectly and give incorrect results when the parameter actually gets passed to the script. There's other options too. If I right-click on the value list tool that I built, it's exactly the same. It has this feature layer friendly rank, but instead of a range, I have a value list. And if I check out what that is, well, this is whatever I want it to be. I can delete and add values as I want. Well, we'll just do 999 there. Click OK. Click OK to save that. And now if I open up that value list tool, I'll select the table just like it did before. And this time, instead of a range, I'm using the value list. I have an actual drop down of the list of the values that I can utilize for this tool. And if I run it, you should see the exact same thing. Yep, just giving us the friendly cats and redlands. So pretty neat way to customize usage of the tool and help your users understand how it works if you aren't able to communicate that directly.
I gotta say though, I think you're violating a couple of the commandments so far.
What?
Yeah, where's your output?
Oh, right.
Oh, yeah.
I was gonna guess.
Yeah, that'll come. Work in progress, right?
Yeah, it's getting better. Yeah.
All right, so off to validation. So we've seen a bit about parameters. Validation is kind of all the other things that happen before the tool actually starts to execute. All right, so there's really two kind of subgroups of what we use validation for. The first one is kind of going beyond just what the parameter definitions give you. It's kind of a way of, additional ways of checking the validity of the data, measuring relationships between different parameters, adding messages that, people can react to before they actually, execute the tool. The second part is it actually plays a role for when we want to use tools in ModelBuilder. So I'll get into that a little bit more in a few minutes, but ModelBuilder kind of works off of the concept that, its outputs are somewhat known, right? So you can chain tools together, and if someone goes and uses your tool in ModelBuilder, they can make choices in a subsequent tool that kind of shows the changes that your tool is expecting to make. More about that in a moment. So there's two flavors again, right? We have the script tools and the Python toolboxes. And the slides I have, I kind of flip back and forth between the two, but really the structure and how it works is really quite similar. So this right here, that's a script tool. So you can see that's a Python toolbox. So in script tool, the parameters are properties of the ToolValidator class. In a Python toolbox, they get passed in as arguments. But otherwise, all the parameter properties, how it all works is, identical. It's just structured a little bit differently. Now, when we're actually thinking about how the validation works and why you use it, it's really just, you're kind of looking at a very small subset of things that are happening, right? So these are parameter objects. That parameter object that we saw earlier in the Python toolbox, same objects. you're really just, looking at what the value is, and then, if it's data, what the properties of that data is. And then there's a couple other flags that you can kind of monitor, like altered and has been validated. And those are really there because there's sometimes when you don't need to make a check, right? Something has already been previously validated. You can maybe skip that check. If something's been altered, you may decide to make a check or not to make a check, right? Now, one key thing about validation code and calling functions on data, so there's a lot of functions in ArcPy and other places that can potentially tap data. Now, because of that ModelBuilder case we were talking about earlier, if you have a tool and you're using it in ModelBuilder, there's going to be cases where the validation code is actually getting fired, but it's on data that doesn't actually exist yet. Right? You can imagine you have a canvas of a bunch of tools, right? There's no data necessarily connected. You go into the dialog, things are happening, right? So Describe can handle that case. It knows kind of what the data is going to be, whereas some other functions don't have that smarts built in. So for instance, if you wanted to do something with like get field information off a data set, right? You would use Describe, not like list fields, because Describe can handle the data does not yet exist cases. So yeah, remember there's two main validation functions that we have control over, right? There's update parameters, then there's that internal validation stage, and then there's update messages. And update messages tends to be smaller bits of code. This is really where you're checking the validity of certain values, based on your own criteria, and adding messages. Right? So there may be, you can't quite check something based on a filter or other aspects of the parameter definition, so you're doing it in here. Now there's only one specific thing I want to get into here, because I trip over this fairly often actually, is I'll get kind of going on my validation code and I'll do something and update parameters, and I'm like, okay, yeah, I'll put the messages type stuff in here. Now this is kind of where the order of how these are called has an effect. So update parameters, really checking, values, changing values, this kind of thing. Internal validation, when it comes in, well, imagine if I added the messages into update parameters. Then the internal validation comes in and it's doing all those basic checks. It's going to actually kind of invalidate my messages and replace them. So it'll work, but you won't ever see it, right? So if you ever have that kind of lost message effect where you're expecting something and don't see it, it's probably just wrong spot, copy, glue it down into the update messages component. The bottom one here, this is, the other thing you can kind of do in some cases, you'll have cases where you actually want to relax messages that might come off of something. I don't use this a lot, but you can actually watch for messages and say, no, actually I don't want that message. You can kind of clear it out so you can have values passed through that might otherwise be held up by just how the parameter is defined. Okay, so this gets into ModelBuilder. So again, ModelBuilder really works off of the output of every tool kind of knowing what it's going to be, even when it doesn't exist. Not like the deep down, like, intricate, features and stuff, but more like, at a higher level, right? It's going to know that data is a feature class. It may have, this complement of fields, different kind of criteria like this. So, and the reason that's important is because when you connect a bunch of tools together, right, in the UI, someone goes in, if the fields are expected, right, they know the field's coming. They run a tool a bunch of times. If it doesn't show up, right, it kind of disables that experience. So we can manage that. This little sample here is from a Python Toolbox, but just through basically altering the schema. Now, a lot of times you're going to have an input and output that are somewhat similar. Right? Your input has some characteristics. The output's going to be something similar but different, right? This might be point, this might be polygon, field might change somewhat, but a lot of things like spatial reference would remain the same. So all you really do is you create a parameter dependency between that input and that output, and then you adjust the schema for what you expect your data to be. So now, someone creates or uses this tool in ModelBuilder, those little pieces will show up as you expect. Now, I have a caveat on this because, yeah, model builder, validation, blah, blah. It's going to depend on what your tool is for, right? If you've got tools that kind of your little in-house thing, and it's really just about kind of building the functionality up, that may not be an investment in time you want to make, right? That's kind of your call. But if you have tools that are kind of more widely used, you're going to give them to other people, you expect that they may use it in ModelBuilder, not a bad investment in time to kind of make your tool a little bit more robust and easier to use.
All right, so we got one more demo. And I'm going to show you real quick the validation aspect of things David was mentioning here. So I've got a third variation of this script tool in which I'm going to open up the properties for that. And in the properties window, I've got the general parameters. I also have this validation section. If I click on that, I see a bunch of Python code in here. Let's see. And in here is where the validation occurs. This is where you code up how you want the validation to work. Now, this kind of acts as a text editor, but you don't have to utilize this. You can actually open the script in the text editor. If you click this button here, and again, it keeps doing that to me. But what happens is you get this, this script here. Let's see, and I'm actually going to use, oh, that's the tool itself. Okay, so let's use this one here. So when you first open the ToolValidator, it doesn't have all this nice code in it. You add that later. It has just these functions, these 4 functions within this ToolValidator class. And these functions all sort of fire off as different things happen as you use the tool. So the doc string here gives you an idea of when these things fire off. The initialize parameters happens when the tool is opened. This one happens whenever a parameter has been changed. And update messages is very similar. When you update something in the tool or change a parameter, the messages sort of do a little scan over your tool to see if any messages need to be reported. So in my case, I'm going to add a whole bunch of code to this, and I'm going to get some brand new functionality out of the tool. Let's just take a look at the tool itself first and see what it does a little bit differently than the others. If I double click on it, open it up, hover over the feature layer, I notice that it says, please select a feature layer with the field friendly in it. So it knows that it wants to use data that has that friendly field in order to work correctly. So I'm going to do that because we have that data. Oh, cool. So when I do that, a new parameter shows up. What? And then if I click on the friendly rank, I get both of the numbers that are available within my table, both a 0 and a 1, basically all the unique friendly ranks. I'm going to select 1. And now I've got this, looks like potentially some output coming from the tool. That's pretty cool. If I just call it output, very creative. I'm going to run it, see what happens. I'm going to guess what happens is that it makes a feature class with only the cats with a friendly rank of 1. And sure enough, if I open up that attribute table, we've got the orange cat and the black and white cat, and both their locations, which are the same as what they were in the source data there. So that's pretty cool. How did I do that though? How did I make a parameter disappear and reappear? If I look at my code for the ToolValidator, what I have here is a little something inside the initialize parameters section. This, remember, is called when the tool is opened. Now it's telling me that my parameters, number 1, is going to be disabled because it has the enabled property equal to false. That's probably why I didn't see it when I opened up the tool, because the enabled property was false. If I look at the update parameters here, though, it's we're going to pay attention to kind of the comments here. If I actually select a feature layer, if it has a value in it, and then I look at that feature layer, and I basically parse out all the field names in that layer, and if I find one that equals friendly, or that is called friendly, then the drop-down option for selecting a unique friendly value appears. So that's kind of how that disappearing act occurs. Otherwise, if I find the data doesn't have that friendly field, I just disable that second parameter again, the one that was reappearing, and I clear out any messages that are there. If I happen to select data that doesn't have that friendly field in it, I want to make sure that the user is aware that they absolutely have to have that field available. So in the update messages function, I've updated some stuff here to check out what the value of the feature layer is. If something, let's see, if it's not set, I clear out any messages that are currently being displayed. I set a warning, which we've already seen, to select a feature layer with the field friendly in it, giving me kind of a heads up as what I should pick. If I have picked a value for the feature layer and friendly is not inside of those fields, then it looks like it's going to report something to me like an error message saying I got to pick one that has the friendly field. So let's actually recreate that. I have some data. Let's see here. I might not actually have any. We could just delete the field. But we are actually running out of time. We have about 3 minutes. Did you have anything else you wanted to kind of mention after this demo here? We only have a few minutes left.
Yeah, no, that's pretty good.
Oh, okay, cool. Yeah. So we could make some data real quick. I think actually I should have something here. Maybe not, but either way, that's basically how the validation works. It's something where you can fine-tune the controls of how the tool interacts with the user, and it creates a really fluid experience for them if you take the time to sort of troubleshoot all of this and figure out if it's working for you or not. Helps kind of reduce the problems that come with trying to predict how the user is going to use the tool as well. You sort of guide them through the process of using it, and makes for a better experience.
Yeah, the one thing that validation kind of gives you is it kind of gives you the checks up front, right? Instead of kind of letting the code kind of go into the, your functional part of your code and get deep in there and fail somewhere. These are kind of like checks you can kind of splash up front, and people, if they're interacting with the tool, can kind of act and respond to that. All right, now we showed mostly Pro today, but I do want to talk a little bit kind of about migration and bridging those two. How many people are using Pro right now? Who's using not using Pro? All right, I expect, yeah, okay. So, what we've seen today is mostly kind of driven from the Pro experience. The desktop experience is a different UI, but it's the same kind of thing. You're building up tools in a very similar way. Now, at some point, some of you might be using both. You might be using just one with some, future eye towards using both. So, if that's a possibility or that's a step you're going to be taking, you can look at a geoprocessing tool we added a couple of releases ago, actually a little more than that, a few releases ago, called Analyze Tool for Pro. So what you do, you just run that tool. You can either point it to a toolbox or a Python file and walk through your code through the toolbox itself and kind of analyze it for any potential issues. Right? Pro has most of the tools that desktop has, but not all of them. Right? There's other small differences that might get caught up. Of course, desktop's using Python 2, Pro's using Python 3, right? There's another kind of potential stumbling block. So the tool will analyze your code, your toolbox for all those kind of things and give you a little report back if there's anything to do. Now, this little site here, I got a book for free a few years ago. I was at actually a Python conference. It's actually, this is kind of outline on the web how you can kind of manage Python 2 and 3 differences. This is something you're going to have to deal with if you're running tools on both. I can't even really tell you now how it influenced my coding patterns, but it kind of reoriented me on certain things to kind of make sure that I was writing code that was safe in both. I think it's been pretty helpful, and most of the code that I write actually, I write some of these script tools and they're going into multiple products. I gotta make sure, right, that it's Python 2 and Python 3 friendly. So it's been very invaluable. The other thing I want to mention is quickly about validation. Validation has historically been kind of, how should I say, awkward to debug. If you've been in there, you haven't really historically had any way of kind of stepping into it. If you watch the plenary, I'm getting my days confused. You watched the plenary, Sean was up there. You guys see that? he kind of stepped through some of the debugging experience. We added that to Pro in just the last release. I'll talk more about that in my session on Friday, but it really will open your eyes to how the validation works and make it easier when you do encounter problems. Oh, it's 3:31, look at that. Let's pause and take a few questions. And then after that, we'll just invite people up.
Is there a session after this? Or how much time do we have left?
Oh, I think we got lots of time, like half an hour probably, yeah. All right, any questions? All right. If you do have questions, you're shy, you just come up after. We'll both be here for as long as it takes to answer what you might have. All right, thank you.